Dear friends, welcome to this class on memory allocation for C data types. This is Manish from Sanfoundry, and I am going to cover in detail about the memory allocation that happens for various data types of C programming language. So let's get started. To begin with, we will do some test like all the other classes. So let's start with the first test. What is the size of memory in bytes allocated by the compiler for character, integer, and long data types? So you have four choices here. You have a character 1 byte, integer 2 bytes, long 4 bytes, and then another choice, and then another choice, then another choice. So before you can get started towards answering this question, I would request you to have a piece of paper and a pen with you, and then try making notes of it. You can also pause the video for some time before you can arrive at an answer. So you can pause and then you can resume. So in this question, we are trying to ask the size of memory in terms of bytes, which is allocated by the compiler. So A, B, C, D, there are four choices. This is slightly tricky question, so let's look into the answer. Answer is still a question mark. Why it's a question mark? Because fundamentally we know that the memory allocation happens on a per architecture basis. So none of these answers are really correct. This was just for us to understand that answers are dependent on some third constraint. So here the constraint is the target computer architecture. Okay, I will cover more about it when I go into this particular class. So let's look into another interesting question. So what is the size of memory which is allocated in bytes by the compiler for character pointer, integer pointer, long pointer on a 32-bit platform? So here, I'm introducing the concept of a platform which says it's a 32-bit platform. So we're looking into the size of memory in terms of bytes, which is allocated by the compiler for some of these pointers. What are the choices? We have first one, then second, third, and fourth. So you can pause and then unpause. The answer is C. We will explain later why the answer is C. Let's move on to the third one. What is the size of memory in bytes allocated by the compiler for character pointer, integer pointer, long pointer on a 64-bit platform? Okay, so we are changing the platform now. We have four choices: A, B, C, and D. And the answer is D in this case. Some of you might be already knowing this. In case you don't know, then I will cover it later. Let's move on to something very interesting now. Okay, so this is the interesting problem. What's the size of memory allocated by the compiler for a void data type in C? So you have a void and then you have a void pointer. Okay, so I repeat, we have to focus on memory allocation for a void data type and void pointer. So I'm giving you four choices once again here. So first choice, 0 for a void and 4 for a void pointer, then 0 for a void and 8 for a pointer, and then the option C, and then the option D. Here you have to think hard and try to understand what could be a good answer. Okay, so you can do a pause and then unpause. So the answer is still a question mark. I repeat, this is a very tricky question because we have to understand how things work in the system behind the scenes by the compilers, right? So I will cover this detail, but some of you might have got an answer as one of these, one of these basically. And there may be a valid reason for that. So we have to understand in that context. So I will cover this topic in more detail in subsequent material slides. Move on to the next question. So what will be the output of the following C code on a 64-bit platform, right? So here we are clear. We are saying that we want to know what should be the output on a 64-bit environment actually. So you have a char C character, basically C is there and you want to display the size. You want to display the size of the variable or the size of the char, right? Okay. So this is a good programming in terms of a proper code. There may be some warnings because the size of returns unsigned long entities on a 64-bit platform, whereas it's a simple value, simple integral values in a 32-bit environment. So don't worry about percentage C, percentage D here. Just focus on this and try to get the values. So again, there are 4 choices: 1, 0, 0, 1, 1, 1, and then a compilation error or maybe a runtime error, right? See, I'm talking about an error here, not a warning actually, okay? So what could be the answer here? The answer is C. Let's move on to the next one. What will be the output of the following C code again on a 64-bit platform? Now here we are taking some pointers, right? So we are talking about a pointer here. The CP is a character pointer, and then we are displaying the values on size of on the star P and sizes on char star. So we have a size of CP 8, 1, 8, 8, 1, or compilation or runtime error. So you can do a pause and then unpause. Answer is B. Okay, so some of you have to think a little hard if you got a different answer. I am going to cover in my lab exercise this particular code sequence. Let's take another one now. What will be the output of the following C code on a 64-bit platform? Now, when you look into this code, we are talking about a variable as a void, and you have a variable pointer to a void, right? So V and VP. We are again trying to display the size of these variables, and then we run this code in our platform, right? So what's the answer? 1, 8 is one choice, then 0, 8, compilation error, runtime error. So please make a note of it and match with your answer. So the answer is C in this case. You will obviously see some big compilation problem in this code. So if you have got it right, pretty good. Otherwise, I am going to cover in my lab for these, right? So what is the purpose of doing all these exercises, right? So the main purpose is to understand memory allocation. And why we need to understand memory allocation? We need to understand it because when you do software development and when we look into the code is generally thousands of lines for a commercial grade software, right? It is deployed in the field in customer places. And when there's a problem at customer side, what do you generally get? You get a core dump, right? You get a core dump, a dump of the entire memory snapshot of your process which was running. Sometimes it is not the process, it can be more than a process, it can be the entire kernel, right? So when you talk about memory allocation, we have to really understand how many bytes are getting allocated for the variables. It can be a global variable, it can be a local variable. How many bytes are getting allocated for the fields of a structure or a union, right? So we need to understand it, whether it's 1 byte, 2 byte, and so on and so forth. Because all this information is useful when you look into the user space debugging, right? So if it is a program crashes, you get a core dump, you have to debug it, you might have to debug it live, you might have to debug it post-mortem analysis, right? Similarly, if you are a kernel developer, you really need to understand kernel crash and then kernel GDB, right? So we'll do GDB analysis. You get a crash file, you do a crash analysis. Finally, you get a memory dump or you generate a dump, okay? So in all of these situations, if we know that, yes, these many bytes are getting allocated in the memory for that, then we know, yes, we have to look into that to display the values which are stored there. Now, at this point, I'm just covering the fundamental, right? The core data type, primitive data types. So we'll cover more about structures and union in a short while, actually, okay, in another topic. So now you understood, the meaning, why it is so important to have the knowledge about memory allocations. So in summary, in a quick rundown, you say character, right? So character is always 1 byte, short is always 2 bytes in terms of size. Integer is always 4 bytes. And then we have a long integer, right? So when you look into this sequence, we have a short integer and an integer and a long integer. These three got evolved because of the evolution of computers or computer programming, right? We used to have 16-bit processors, then we have a 32-bit processor, then we have a 64-bit processor. So earlier we used to have an integral values or an integer which are really short in size. So they're really short, actually small numbers. And later we have a 32-bit environments where said, we have slightly bigger, they're really integers. And then we have 64-bit environments, we want it much bigger, right? So it is a long. So short is 2 bytes, integer is 4 bytes, and then long, depending on the computer architecture, right? So this is depending on the platform, it changes the value. Float is always a 4 byte and double is always a 8 byte. Void, even though we consider as a primitive data type, but remember void basically says nothing, it means nothing. So we are not going to allocate any memory for a void kind of a type. So if you say I want to do a void x is a variable, right? That doesn't have any meaning actually. Okay, so compiler says I don't know what do you want to say when you say void x. Okay, so void was primarily created in terms of pointers. So we need to know if the pointer is returning some memory address, what data type, which kind of pointer is going to point to it. So sometimes we don't know, the memory allocator just don't know who is going to use actually. So it returns a void pointer. Okay. In one of my previous presentations, a class I have told about malloc. So there I showed you malloc is returning a void pointer. So void has a very different meaning, in terms of data types, right? Okay. And also a function can return a void, which means the function does a job. It is not supposed to return anything to the caller, the person who has called them, right? So it's just a void, it just does the job. So we will cover a little more about it. Now, just important thing also to know is that when you talk about memory allocation for a data type, whether it is a signed entity or an unsigned entity, it's fixed. So when you say it's an integer, so signed integer or unsigned integer, it just doesn't matter. Integer is 4 bytes. So whether it is signed or unsigned is immaterial for the total amount of memory which is allocated for integer, which is signed versus unsigned. However, when you go into the memory for further troubleshooting, you must know whether it is a signed value or an unsigned value, because the representation has a different meaning and how we deduce those values have a different meaning actually, right? Okay, so long I had also covered in one of my previous presentation classes, right? So I'll quickly talk about it. Long type was generally created for a 32-bit environment, and then long is 4 byte and 4 bytes. So totally we are talking about 8 bytes on a 32-bit environment. Okay, so long was created for 32-bit, and it does not have much meaning outside 32-bit environment, like it does not have meaning for 64-bit environment actually. When you look into the sizes now, character, it doesn't matter the qualifiers, all are 1 byte. Integer, all are 4 bytes. Short, 2 bytes. And long is again 4 byte in a 32-bit world. Okay, so in a 32-bit world, long is 4 byte. Long was primarily created for a 32-bit world, so long is basically an 8 byte, doesn't matter the qualifier. Okay, float is a 4 byte and double is a 8 byte. Why do we have these as two different sizes? Because it stores, if you look into double, it stores 10 digits of precision. So it is a very high representation, very accurate representation of those numbers. The float was 6 digit and this stores 10 digits. So I think, so we require more space to store them basically, right? When we move into a 32 versus 64-bit kind of comparison, as I mentioned in the previous slide, everything is same except for the interpretation of long. So long is a 4 byte in 32-bit and long is a 8 byte on a 64-bit environment. Similarly, we have long. So long was created for a specific purpose on a 32-bit world. So long became a 8 byte entity, long on a 32-bit world. However, when you extrapolate it and move it into 64-bit environment, don't think that long is 8. So we will have long as 16 byte. No, long is just a long in a 64-bit machine. So it is still an 8 byte entity. Okay, so I think these are some of the differences, and one more difference which I have not covered was about pointers, right? So I will cover that with an example itself actually pretty soon. So what we will do now is we will have to do a live example in terms of understanding both. There are two things we are going to understand in this. We are going to understand the memory allocated for almost all of these, so we have to write a program which should run on a 32-bit platform and a 64-bit platform, and then it is going to give answers for all of these. So we are going to understand the real fundamental data type sizes. So this is a very good program for you to deduce the data type sizes for your target platform. You can easily deduce it, right? You can run and then do that. We'll also understand some vagaries of usage of some of these, in terms of size offs, as well as I talked about void data type. And any idea when you look into the last line, what should be the return value in terms of size of, right? Size of 100 and FFs, 8 times FF, and then we have 10 times FF, right? Whether it returns some value or it just returns some error, right? So we will try to see this with a live example. And with that in perspective, I'm just moving into a lab exercise. And in the lab, we'll do a Sanfoundry data1.c actually, right? So let's move on to a lab. And what we will do is we'll go to a lab and we will run this code, we'll modify. So let me explain you, this is an x86 64. So my machine is a 64-bit machine. So this particular virtual machine that I am using is a 64-bit environment, okay? So let's go ahead and try to look into the code. I have already coded it for you basically. So we will explain one by one. So here is the assignment, write a C program to display the value of almost all of these actually, right? So we'll go one by one and try to get the answers. Everything is commented out. Now, important thing here is when you try to code some of these values, when we try to code some of these actually, right, we have to understand clearly how we are coding it. Since I've already coded, things look easy, but when you code yourself, believe me, you'll have a lot of errors initially if you're not a very frequent programmer in C. Okay, so any idea what would be the output of the very first printf and what would be the output of the second printf? Okay, so this is what I am trying to focus at this point of time. These are the two lines. So how do we display the size? How do we calculate the size? You can simply say size of character. What is character? It's a data type, right? So you can always have any data type defined. It can be primitive data type, it can be a user defined, it doesn't matter. So you can supply the data type itself, or you can supply the name of the variable of a particular type. Okay, so sometimes what happens is when you use the name of a variable, you don't know what that variable type is, what that variable is all about. So when you look into the size, you simply say size of that particular variable name, and it will give you, yeah, this is the size of that object, right? It's a good way. So both ways should give the same answer. Okay, so let's try to run this code. So I will just run this code to get a warm up for us. Remember, this is a very exhaustive lab in this particular thing, and we are going to learn a lot of things. So it looks simple, it's all printfs, but we have to understand line by line what's the meaning and why it is coming like that. So the first one was printf, and any idea what should we get is we are talking about size of character and size of C. Both are technically absolutely the same thing, right? So we'll do a CC on Sanfoundry data1.c, and I think you guessed it right. You get a value 11. Let me comment out some lines. It is coming from bottom. Okay, so yeah, so I'll comment out this line because that's not the focus at this point of time. So let me clear up. We'll run once again. Sorry, let me clear up once again. Yeah. So, oh, my mistake. I'm really sorry. To compile it, right? So we'll compile it, we'll do an a.out. Yes, so we get the data. So what you are seeing here is basically you are seeing 1,1 because it's a character. When you look into the code, we are talking about this character and character. So I think this much is clear, and let's move on to the very interesting one. This line is very, very interesting. Okay, so size of CP. What is CP here? CP is basically it's a pointer. It's a pointer to a character or character pointer, right? So we are trying to display the value by saying, yeah, I want a character pointer PTR, or I will say size of star CP or size of CP, right? So now remember, there is a significant difference between these two. So we will run this code. You can also think about for just a second, what should be the value of this? And I'm running this code now. So let me go back on the previous case and we'll do a compilation. Yeah, compilation is required and then a dot out. So what you see is 8, 1 and 8. Now this is interesting. Some people always fumble, right? People who are not a frequent programmer in C. So what is this? We are really talking about a character pointer. So character pointer, what is the role of a character pointer? What is the role of this CP? CP is a character pointer. It's going to store the address of a variable on an 64-bit platform, 8 byte, right? Addresses are 8 bytes, so it is going to store an 8 byte addresses, right? So when you talk about size of character pointer, it's going to be 8, which is absolutely true, and that is what you got it. Now look into 1,8. So what is size of CP? So there are two interesting things here. I repeat, see what is CP? CP you know is a character pointer. So which means that CP is just a variable of type character pointer. So CP should store an address of a memory location, and that location type is just a character, right? So it is going to store the address. So this is the third, or it is the third one, right, in this printf. So you'll have 1, 2, 3, third format is specifier, or the technically fourth argument. This is first argument, this is second, this is third, and this is fourth. So if you see this guy, so the answer for this line is 8, which is true. It's an address, right? It stores an address. What about size of star CP? Now this is interesting because CP is a pointer. And what is the meaning of star CP? People who know pointer, they understand that, it's an indirection. We are jumping into that location. So we jump into that location, and that location is nothing but a character. It is holding a character. It's a character data type. So what we are essentially saying is, if you jump into that location, tell me the size of the data which is going to be stored there, right? So you know that it's a character. So size of that is generally 1. So that's the only answer you will get here. So the middle value is 1, right? Yeah, so I think that's what I was telling you. We need to understand some of this data and by playing around with it. So I have given a short in these 2 lines. So I think short is fine. And similarly, we have, the another variation that you see here, size. So it's a character. So same thing will repeat here, short. And then here you will have a same problem, star SP. That will not help, right? So you will have the same problem on star SP. So if I compile this quickly, compiled it. So what you see is size of short is 2, 2, whichever way we write, it's a 2 bytes. And then the pointer for that is 8 byte. A pointer is always 8 byte. You can see it now because a pointer to anything, pointer to a character, pointer to a short or an int or a long is always an 8 byte because it is holding an address 8 byte on a 64-bit platform. And now it is the indirection as we discussed, right? So star SP, it goes into the location. In this location, yeah, it is just a memory address for some data type where it is going to store a short value, right? So the value, so short data type is 2 bytes. So I hope, this is making things clear for all of you. Similarly, when you talk about integer, when you talk about long, float, and then double, so there are, these are interesting ones. So interesting but simple now, I think we all know. So we can write in terms of, always remember, we can write in terms of data type, or we can write in terms of variable that is declared or data type, right? Okay. So when you compile this and get all the 4 lines for 1, 2, 3, 4, and get this out, what you see is we compile it, right? So your size of integer 4, 4, long is 8, 8, float is 4, 4, and double, it's a double, right? So double is 8, 8. Okay. So we can use both mechanisms to get these values. So when you see this, basically you can use both of these mechanisms to get this value, right? Let's look into this another very interesting one. So far we are talking about this size of void pointer in a VP and then printf v size of void, right? So we are talking about these variables, all these while it was commented out, you can see that, okay, it was kind of commented out. So let me uncomment this. So void v and then star VP. So we are talking about void and star VP, okay. So let's have a focus. We will see the compilation and let me put the line numbers for this activity, okay. So we should understand why I put the line number. Let's compile this and then we will come back into this code to understand. So straight away there's the compilation error. It says that the variable or the field, and the name of that is v declared void. So there is a problem at line number 25, right? So when you look into line number 25, exactly, it says there's a problem void v. That's the one, void v, right? So it's always good to put your line numbers whenever you're debugging, unless you're a very pro and you pretty much understand where you are in your code. Okay. So when you do this, what you are seeing that there's a problem, because as I told you early on, void is not truly a data type in terms of sizes. So we cannot declare a variable of that type. However, we are free to declare a pointer to that. Remember, VP is a pointer to a void. So it is pointing, it's storing an address of somebody, and at this point of time, we don't know who is that somebody. Is it a character, or it's a structure, or it's an integer, or anything else, right? So this is perfectly valid. So VP, so let's focus on VP now. So size of VP, or a white pointer or a VP, right? So we'll discuss size of here and then a VP actually. Okay, let's see this, and this let me comment out. So we'll focus only on this line at this point of time. Okay, so we'll compile this. So this time compilation is through, and then you know that size of white pointer is 8,8. Basically both ways we are getting it, because I told you now a pointer is a pointer, doesn't matter. I repeat, a function pointer also is a pointer. It stores an address. It has to be a 8-byte entity on a 64-bit platform. Next, and this is where people have doubts, because what has happened is we have declared size of v now, correct? So there was a v here which I commented out, and what we are doing is we are trying to do a size of void. So we are not saying size of v, because compiler does not recognize v, saying that okay, v, you are declaring an object but it is void, so I cannot recognize you. It's an error. So instead of writing v, I am writing the data type called void, and then let's run this code. And these are the gray areas in which people have problems, okay? Problems understanding it. So when I run this code, it will happily throw out 1. 1. So the problem is why it's 1 actually, right? Because void means nothing. Now I think this is just an implementation choice, okay? So what it really says is that I have to I have to reduce the size of this computation for a data type. So size of generally gives you the size of the computation. It expects something here. If there is nothing, if it is a void, I think it just defaults to 1. Technically speaking, it doesn't make sense, because void means nothing. So I should return 0 for reasons I don't have idea at this point of time. Okay, but it just gives 1. So it gives 1, but don't assume that the size of void is 1. No. Anyway, you can't declare a variable of that type, which means you can't declare an object, right? So it's kind of meaningless. All right, so here pretty much done. So let's look into the very last part in terms of 64-bit environment. Size of 100, right? Size of f, 8 times f. I've written here 8 times, and size of f 10 times. Okay. So what the point here? What are we going to achieve here, right? So we wanted to know what the size of return when you write 100. What is 100? 100 is just an integer. It's an integral values. Okay. So what sizeof basically does is it looks into the arguments. If the argument is an integer, it's like some integral value. It knows internally it is an integer actually, right? So C programming, pretty much these are integer values. If it is some numerical value, yeah. If it is a real number kind of a thing where you have a decimal and some dots, numbers after the decimal dot, then it's a double or float values, right? Anything other like a whole number or integers, those numbers are technically integers here. Okay. So this is an integer. What is the data type for integer in terms of memory allocation? 4 bytes. So by default, this will be 4 byte now. Same thing, f, how many times? 8 times f, right? So when you look into the numeric representation of this hexa, right? So when you look into this representation in hexadecimal, when you look into ff is basically, it can be stored in a single byte, as the largest value, then another ff. So totally we are looking at 1 byte into 4, so 4 bytes. So 4 bytes, so this number is the largest possible unsigned value kind of stuff, right? Basically, so this number can be stored in a 4 byte entity. So this also is a 4 byte integral value. So it is an integer. When you look into ff, so here f is 10 times, right? So when you count ff, then ff, so 1 byte, 1 ff, 1 byte, 5 of them, you require 5 bytes. So is the size of for that is a 5 bytes. So that's what we have to think. In reality, an integer value cannot be, in terms of bytes for every new values, right? So it has to be in bucket. So it has to be an integer if it is any value which is less than or equal to ff this value. But anything more than that, it has to, upgrade itself to something like a long data type, correct? So even though we say that we require only 5 byte to store, but in reality, we have to upgrade into a long integer value. So this has to be a 8. So this is 4 as an integer. This is the largest integer, hopefully. So 4, and then this is 8, right? And that's what when you compile this and run this particular code, you get a value of 448, right? So 448, and that's what we have deduced here. So the summary of this entire exercise is twofold. You have to really do it. Even though I have given a demo, you should do your own coding, right? Coding will make you perfect in terms of writing this properly. I have seen in my classes many people understand it, but when they need to write, they fumble, right? There will be some issues here and there, and then sometimes it is difficult for them, to fully write it properly. Important thing to remember is the difference between a pointer dereferencing and a name of a pointer. Okay, so here a lot of people create mistakes. All right, so I think this is the talking about memory allocation for fundamental data types. Let me quickly jump over into a 32-bit environment now, right? It's a 32-bit environment. So I do have a 32-bit system right with me. So just give me a second and I'll go into a 32-bit system. Okay. We'll not go so elaborately on that. We just need to, understand few important things in terms of data size. So uname -m machine. So this is i686 system. It's like a slightly older version. These are Intel series. So 386, 486, 586, 686. These series are generally a 32-bit environment. This is how, we can figure out, but the best way to figure out is write a code. And that code is again your size of for all the fundamental data types that I have covered. That will give you a very good idea about your platform. Okay. So what we will do now is we will not really delve so much. This is the code I have taken, a small portion. So we need to understand the size of a character and a character pointer. So size of a character can be written like char and then C. And here it is the char pointer and a CP. So we'll see what that pointer and this is. Similarly, integer and long. So long, as we know, is going to be slightly different. It's a 32-bit platform. And long is going to be 64 here. Okay. So let's compile this code and then we'll run this code. So you get character pointer, you get a character as 1 byte, in both the styles. Character pointer is 4 bytes. Remember, it's a pointer, 4 bytes only. Integer 4 byte, long 4 byte, 32-bit environment here, right? And then you have a long. You have a long, which is designed primarily for storage, databases, very large scale data sets, right? So terabytes of data, which cannot be represented easily in 4 bytes. So there was a requirement for a 8 byte type, which is added to the C programming language. So pointer. So we talked about pointer. So pointer is also 4. So pointer is 4, long is 4, integer is 4, right? So in this class, so far we have covered, the details about the data type memory allocations. Okay. In the next class, along with the lab, I will talk about derived data types, structures and unions, and some allocations for space allocations for that, and as well as arrays and function pointers in terms of space allocations. And we'll also talk about internal memory representations for them, right?